One quarter
special.
is full.
Something special.
All right, we're ready to start.
Yes.
Happy New Year. Good to see everyone. So tonight we'll dive back in a sense, but there is a little bit, I think, of a reward with hypothesis testing, because this is a point where you start to see how your knowledge of statistical theory, that I think you've worked very hard to develop, applies to more straightforward questions. So you'll pose a question, a hypothesis. You'll say, is the mean greater than this amount? And you'll try to prove or disprove that with the statistical theory that you already know. So by definition, it's that link of practical questions and underlying theory. So, with that, let me start. I'm going to go through a couple of exercises that are in your textbook. And if you'd like to follow along, that is fine. I'm going to start with 9.2, and then I'll do 9.6, and then I'll do 9.7. So, let's just start right off the bat with 9.2. In this situation, apparently, you are talking to some realtor in St. Louis. I don't know, actually. Yeah, 9.2. Yeah. So you're talking to some realtor in St. Louis, and this realtor tells you how great property values are, how he can get you a great rental price, and he says that the average rent for a one-bedroom in St. Louis is less than $1,560. Alright, so that's what the realtor says. Average rent for all apartments in St. Louis in this category, less than $1,560. Now suppose you're a little suspicious about what this realtor says. You kind of creepy vibe, he's trying to sell you something. For whatever reason, you're not sure if you trust the realtor. What could you do to test whether or not you think the realtor is correct? Yeah, we could go do a sample, right? So the realtor has told us, according to him, that the true population mean is, let's see, is less than or equal to 1,560. Alright? And you're a little suspicious about that. So what if you were to go out and get a sample of your own? Alright? You sample the number of apartments, use good sampling techniques, good procedures, and you come up with a different number. Alright? And you could do what we've learned to do, which is build a confidence interval around this number. Remember, we do a 95% confidence interval? And if 1560 is not contained within that confidence interval, you might say, aha, I have statistical evidence that you are incorrect, that you're giving me false information. So that, the underlying theory of what we just talked about right there, doing a sample and building a confidence interval, that's essentially what we're going to do tonight, just in a slightly different format. So let's do it this way. Let's say we're going to assume what the realtor says is true. And let's call this our null hypothesis. Alright, let's notate it with a little h with a little subscript 0. That's our null hypothesis. We are going to assume it's true unless we have overwhelming evidence to the contrary. If we find overwhelming evidence to the contrary, we are going to reject this null hypothesis, and we are going to assume the opposite. And what is the opposite of the population mean is less than or equal to 1560?
Equal or greater than?
Yeah, so it is greater than 1560. I'm glad you said it just like that, because this includes everything. In this null hypothesis, we've got 1560 and under, and this we've got anything over 1560. That's fine. I mean, it's not. It's just this is an important point. So if it's right at 1560, we're going to say, okay, it's still true. You know, I got a little. Yeah, all right, but you're cool. You're good. But if it's anything greater than that, then we're going to be mad. And let's call that opposite the alternative hypothesis. This is the alternative hypothesis. Okay. So let's go out and get some evidence of our own. Let's sample 50 apartments. Okay. So n equals 50. And we find a sample mean of 1586. 1586. All right. Now, what do we think just based on that information?
That he's false.
Yeah, we're thinking we like this realtor even less now that we have a sample mean that is above 1560. And he told us that the true population mean is less than 1560. But here's the thing. This is just a sample based on 50 points. It is possible that this could still be true, and we could have just randomly selected a bunch of expensive apartments. That is possible. But let me ask you this. Do we have a way of quantifying that if this is true, what is the likelihood of this sample outcome? Do we have a tool, a method that quantifies the likelihood of any sample outcome?
The answer is yes, I can't recall right now.
Yes. Yes. The interval, you're on the right track with the interval. What is that underlying tool that gives us the interval?
The standard deviation.
If I remember last time I told you if I had $1 for every time I said this, I would be rich.
The standard
Matter
error.
of fact, correctly, you're right.
What is the tool that tells us the likelihood of any sample outcome?
That's the sample.
Location? Yeah, Z table. Well, what are we going to look on to calculate that Z table? What's the thing we know and love?
I know I would not answer.
It is the sampling distribution of the sample mean. All right, we know this. We know it is normally distributed. We know that the center of it is the true population mean, and we know the likelihood of any particular sample outcome. So let's assume the realtor is telling the truth, in which case the mean of this distribution, we're going to take the equal part. We're going to go right up to the edge, giving the realtor the benefit of the doubt, go right up to the edge at 1560. And we're going to say, all right, sort of the worst case of what you say would be that the mean is equal to 1560. Okay. And we found a sample mean of 1586. All right, sample mean 1586. Okay, which was right there. Now, if we had found anything less than 1560, we'd say, all right, Mr. Realtor, you're cool. You're right. We don't have any problems. We find anything more than 1560, we get suspicious. Now, if it's just a little bit more than 1560, we're like, right, it's possible that this could still be the mean, and you could get a sample that's a little bit higher than that, right? That's fine. The further and further we get into this tail, the more suspicious we are. And at some point, we're going to have to say we're so suspicious that we do not believe what you're saying, and we are going to reject your statement. And we are going to assume the alternative is true. Okay. So now suppose also we happen to know that the population standard deviation is equal to 100. So the question is, I want to know the percentage likelihood of this particular outcome. More specifically, the chance of being this far away from the mean. Like, what's the probability of being in this tail? 1586 or above.
Very unlikely.
Yeah, tell me the exact number. I'll give you a hint, you're not going to be able to do it in your head.
Okay.
How are we going to find it?
Table?
Yeah, the z-table.
Okay.
Alright, so the first thing we need to do is we need to assign a z-score for this sample mean. Remember on the first day of class when we assigned Evander Holyfield a z-score for his height? And we said your z-score is like 2 point whatever. That means that 2% of people are taller than you, 98% of people are shorter than you. Same thing here. We want a z-score for this sample mean and say 2% of sample means are bigger than you, 98% of sample means would be smaller than you. And that 2% is going to be the chance of being in this tail. So how do we give this a z-score?
X minus
Who's that?
He's talking.
Okay.
mu. Wouldn't it be x minus mu over 50?
Close. No. No, not close. 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 I'll say close. I'll give you close. Alright, so x minus mu. I like where you're going. So let's call this the z statistic. Z stat equals
1586 minus 1560 over.
Standard deviation.
yes. Standard
Square root
deviation.
of the number
Yes.
of your sample.
Yes. It's our standard error. Alright, so what is the standard deviation of the sampling distribution of the sample mean? We know the mean is 1560. What's the standard deviation of this? Darlin just gave it away. It is, oh wait,
And the root square of the sample?
it is the population standard deviation divided by the square root of the sample size. Yes. And that is, what does that come out to? 100 divided by the square root of 50?
I'd say just the root square of 50.
14.14.
Yeah, 14.
Outstanding. Alright, so the standard deviation is 14.14. Now our z-stat is going to be 1586 minus the
1560
true population mean. Excellent. 1560.
over 100.
Over 14.
Yes. Okay, so this is the difference. This is how far above the mean it is. Now is that a big difference or a little difference? Well, it depends. If it's like 5 standard deviations, then it's a huge difference. If it's like 1 standard deviation, it's not a huge difference. So we divide that by the standard deviation, which is 14.14. And what does that come out to?
1.84.
Yes. Excellent. So now we have a z-score for this sample outcome. Just like we had a z-score for Evander Holyfield's height. And once we had Evander Holyfield's height, the z-score for that, we could determine the likelihood that the next person who walked by would be taller than him. So tell me, what is the likelihood of getting a z-score this high or greater? I want to know the probability of being in this upper tail above a z-score of 1.84, also in this case above a sample mean of 1586. When you find that, we're going to call that a p-value. All right, that's the probability of that particular outcome. Said another way, the probability of a value that extreme. Alright, so right now you're looking for the p-value. Probability of that outcome.
And how do you do that?
Oh, I thought you were working on it. I'm asking you. Alright, what's the likelihood of this outcome? So if you have a z-score of 1.84, alright, what's the probability of having a z-score greater than that? That's it. The probability of having a z-score greater than that.
3.29%.
3.29%? Fantastic. 3.29%. Okay, what Tay did is he looked up 1.84 on the z-table, and he said 3.29% of the area is above that, and 96.71% of the area is below that. If he was looking on the positive, he may have seen 0.9671, and he said, well, that means there's 3.29% above that. Okay, is everyone with me to there? Alright, so the realtor told us that the average rent is less than or equal to $15.60. We were a little suspicious, we did some testing of our own, and we got a sample mean that was higher than that. So right away we were like, I'm not sure I believe you. In fact, I have evidence that indicates that you're not telling me good information. How compelling is that evidence? Well, if what you say is true, then there is only a 3.29% chance of my sample outcome. You with me? So given that, we now have to answer the question. Do we believe the realtor?
Yes.
Yes. No,
Not yet.
because,
Not
Okay.
because he said it would be under, right?
Yeah, he said it would be under 1560. It wasn't under 1560. But just because it wasn't under 1560, that doesn't mean we don't believe him. I mean, because it could be just a little bit over, and we're like, okay, that could happen by chance in our sample. But the further and further it gets, the less likely we are to believe him.
Okay.
And we are able to quantify it. That if he's telling the truth, there's only a 3.29% chance of that outcome. So let's make the case. We want to make the case for yes, we believe him, make the case for no, we do not believe him. Alright, so let's, why don't we divide up? Like front row, you want to do yes, we believe him? Okay, back row, no, we don't believe him. Alright, so talk amongst yourselves. How are you going to, why would you believe him? In the back row, why do you not believe him?
Initially, I said.
I'm still on I'm still in business.
So what is he asking? To see if we believe?
Tell me why you don't believe him.
Based on that calculation?
Yes.
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 And it's 3.29 above, but the sample we got was above.
Okay, I believe.
You believe him? But you're going to make the case for no, you don't believe him.
Oh, I'm supposed to make a case I don't believe him.
Yes. Why? What evidence do you have to say you don't believe him?
That the rent is below 1560 or is above?
That this is untrue. You're going to tell me why you reject this hypothesis.
There's only a 3%.
I'm supposed to how?
Being great.
There's more people on that side than that side.
No.
Who can make the case?
The no? The no's? Do we have a case for no?
Then we
No?
yeah.
Not yet.
You know why? The New York City can't get an apartment.
You want to switch to no?
I'm saying no.
Huh?
I'm saying no.
Alright, Adamus is gonna switch, he's gonna be on yours.
I want to say something, okay.
Yeah,
Okay, so then I thought that, yeah.
Wait, you gotta make one case or the other.
Okay.
It's 3%.
On the one hand, the other end.
Okay.
Alright, are we ready for a case for yes?
Yeah.
I guess so.
Alright, we have a case for yes, and do we have anyone making a case for no?
Who's gonna speak? You?
This is a very trusting crowd. No one wants to make a case for no. I mean, I've seen people convicted on much less evidence than this.
Oh, no. Oh, my
Okay,
God.
but the p-value is in agreement with what the realtor said, or is it rejecting?
Okay,
Yes or no?
No, that's the
You're-
percentage, is
It's
that
saying-
3% that he's right, or 3% that he's off from?
3% that he's right.
Okay.
3% that he's telling the truth. Yeah, there's a 3, yes, 10.
Well, we don't believe him just because, it's 1.84 standard deviation from the mean. As you go further away from the mean, the chance of it happening is less likely.
Yes.
And so the probability of that, him telling the truth is, in this case, a little wrong.
Okay, so
We don't have anything concrete, but we have like at least almost 95%,
yeah, okay. All right, so you are almost 97% certain that he's lying.
Right.
Okay, but you said you don't have anything concrete. At what point do you say you have something concrete?
well, we have to determine what our level of, what to us is acceptable as far as how, the deviation from the mean is
Yes.
acceptable.
Yes. Well, so what is the acceptable level to you? At what point do you stop believing the realtor? When this gets down to 2%, do you stop believing the realtor? When it gets down to 1%,
Less than one.
less than 1, you're going to stop believing the realtor?
No,
Yes.
Personally,
I'm
would
not
say
even believing him now.
10% I wouldn't believe him.
Okay, so 10%. So you say, Adamus, you say 1%. Anything less likely than 1%, you
Less
reject
than
the null hypothesis. Tay, you said anything less than 10%, you reject the null hypothesis? Okay, so Tay is a little quicker on the draw. He's not willing to believe anything less likely than 10%. Adamus has a higher standard of proof. It needs to be less likely than 1% before he's going to call you a liar.
Hey, you never know.
Okay, so what we've just been discussing is what you mean by overwhelming evidence. Remember we said we're going to believe this unless we have overwhelming evidence to the contrary.
Right.
And you, as the statistician, get to decide what is overwhelming evidence to the contrary. And it sounds like, right, and we're going to call this our significance level. And we're going to make this little funny symbol. And suppose our significance level is 10%. Alright, this is Tay, 10%. Anything less likely than 10%, he is going to reject the null hypothesis. And he's going to say, Mr. Realtor, I'm canceling my contract. I'm going to write you a bad Yelp review. Okay, so what, if the p-value comes out to be 3.29%, what is Tay's decision? Is he going to reject the null or fail to reject the null?
It's gonna be
We
reject.
We have,
He's going to reject.
He's gonna reject the rule.
He's going to reject the null. Okay, what is Adamus's decision? Because Adamus has a significance level of 1%.
He's gonna accept it.
He's gonna accept.
We're going to actually say fail to reject. Alright, he's not saying I believe the realtor. He's saying I don't have enough evidence to call you a liar. You never know. That could happen 1% of the time. So in this case, 10% significance level, reject. And a 1% significance level, fail to reject. Okay. So, the case for why the realtor is lying to you, why the realtor is wrong, is that there's only a 3.29% chance that the realtor is telling the truth. I mean, do you really want to trust someone if there's only a 3.29% chance they're telling you the truth?
No,
Yeah, probably not.
it still could be possible.
It's still possible. You may not want to send them to jail. You know, you may not want to cancel a contract where you have a huge cancellation fee. You may not want to shift your manufacturing plant from China to somewhere else. Right? You may need overwhelming evidence before you make those huge decisions, but still you're awfully skeptical. Okay. The case then, so that's the case for why the realtor is not telling you the truth. The case for the reason the realtor, or why the realtor might be telling you the truth, is because these kind of outcomes happen 3.29% of the time. Alright, as you're like grabbing a realtor, telling him you don't like him, he's like, this happens 3.29% of the time. You took a stats class, you know 3.29% of the time, you get these crazy sample means. It's not my fault you got unlucky with your sample. But that brings us back to what we're willing to believe. What is our threshold? What do we mean by overwhelming evidence? And we get to decide. We could decide 10% is enough evidence, and we are going to reject the null hypothesis, anything less likely to happen than 10%. Or we could decide we need a higher standard of proof than that. It needs to be less likely than 1% before we will reject the null. All right, good. We're going to talk a little bit more about this, but let's just take a breath right there. Good job. So we've got a good chunk of hypothesis testing under your belt at this point.
I'm full.
Yeah. Okay. So, let me add one little nuance to this. Let's, instead of waiting till we calculate the p-value, let's set up our test in advance. Let's say that our chosen significance level is going to be 1%. Alright? Before we start this test, we're going to say, before I even see the sample results and my blood starts boiling, I'm going to make a decision of what my decision is going to be. And it's going to be a significance level of 1%. Anything less likely than 1%, reject. More likely than 1%, fail to reject. And I want to set up what I'll call critical values. Alright, a value beyond which I am going to reject the null hypothesis. So, if my significance level is 1%, what I want is I want the z-value cutoff point that separates the upper 1% from the bottom 99%. And I'm going to call that my z critical value. Z, put it a little bit over here. There it is. Alright. Let's do it, yeah. Let's do it right here. Z critical value. Alright. Alright. This is the top 1% of sample outcomes, and I'm going to call this my rejection region. Rejection region. Alright. I would like to know the z-value that separates the upper 1% from the bottom 99%.
2.33.
2.33. Alright. So Tay looked in his chart, he looked for 0.99 in the center, and he said, oh, that's a 2.33 z-value. Okay? So I've set up my critical value, and I know any z statistic greater than 2.33, my conclusion is going to be reject the null hypothesis. anything less than 2.33, my conclusion is going to be fail to reject the null hypothesis. So those are two ways to frame our decision. The first way is we look at the p-value. If it's less than our significance level, reject. If it's more than our significance level, fail to reject. The other way to set up this test is with a critical value, and if the z-stat is in this case greater than our critical value, reject. If it's less than our critical value, fail to reject. In this tail, this rejection region, it could also be in this side, depending on what our hypothesis is. And we'll learn in a minute how it could also be in both tails. We could have one rejection region over here, one rejection region over here. Yes,
I'm
Karen?
sorry, how did you get the 233?
Okay, so the 233 was based on our 1% significance level.
Okay.
So anything less likely to happen
So
than
you had to go
1%?
to 999 and get the Z score, okay, sorry. You're doing this on
Okay. Yes, Roxanne?
Just to repeat, if the p-value is more than the significance value, we reject. If the p-value is less than the significant value, we fail to reject.
I think it's the other way around.
So if the p-value is less than,
If the p-value is less than the significance level, reject.
reject. Okay, thank you.
Thanks. All right, excellent. Let's just do a sample exercise. If you could open your textbook to chapter 9, and let's do exercise number
Isn't
6.
it the other way around? If it's less, greater than the 2.33, then we reject?
It's critical value region, okay. So the critical value is the opposite.
Oh,
Yeah, so if our z-stat is greater than the critical value, reject. If our z-stat is less than the critical value, fail to reject.
okay.
Failed to reject.
Now that's going to get extremely complicated if you just try to memorize that, which is why I suggest you don't just try to memorize that. You always draw the picture, draw the rejection region, think it through, say, is this in the extreme tail? All right, that means this is extremely unlikely, reject. And then think through what does the p-value mean? All right, that's the probability that the realtor is telling the truth. The smaller that is, the less inclined I am to believe him. And the more inclined I am to reject the null. All right, I'll pull up number 6 on the board. I'll give you a couple minutes like we always do. Just look at it, talk to your partners about it, try to think through how you're going to frame this and answer that question.
Yeah, that's.
She scored, she gave us our grades already. She just gave us our grades.
That's my book. She really wanted to know
I got 95.
the dark side.
She made the comments.
So, we reading the one that says according to research? The one that says according to research? Six. The one that says according to research? I don't know. Yeah.
That's the location.
322.
Thank you.
stat is the number,
Yes.
right? So if it's more than that number, then it rejects.
Amanda, what's the significance level?
It's more than which number?
The
The
Z
Z-score.
Right.
If the Z-stat is more than the
One
Z-score,
and one?
then we reject.
No, the Z stat is more than the CV, critical value.
And fail.
I'll get a little homework.
You should have done this the first semester. Oh, yeah.
That was New Year's. Hey guys, on the last sentence of information, since the hard drive is 0.4 years or 4 years? Right? Yeah.
All right, are we ready to do this? Ready to start?
Oh, you did it? No, what's that? That's probably 6.
All right, so in this case, we are given the null and alternative hypotheses. The null is that the true population mean is greater than or equal to 2,000. The alternative is just the opposite of that. So we are going to believe the null hypothesis unless we have overwhelming evidence to the contrary. What do we mean by overwhelming evidence? Well, in this particular case, we mean something less likely to happen than 1%. If we get a sample outcome that is less likely than 1%, we consider that overwhelming evidence and we reject the null hypothesis. So we went out and we got some sampling evidence. We sampled 100 points of data. We got a sample mean of 1955, and we happen to know the population standard deviation is 150. So if the null hypothesis is true, then the sampling distribution of the sample mean looks like this. The true population mean, we're going to go all the way up to the edge, the equality part of the null hypothesis, and say the true population mean is equal to 2,000. If it is anything greater than 2,000, then we're not even going to worry about it. Our sample mean comes out to be greater than 2,000, we're like, okay, the null hypothesis is greater than, but if it's anything less than 2,000, we get suspicious. And the further negative it gets, the further in this tail it gets, the more suspicious we become. So, the mean, if the null hypothesis is true, the mean is 2,000, and the standard deviation of the sampling distribution of the sample mean is the population standard deviation divided by the square root of the sample size. What is that in this case? Yeah, it's 150 divided by the square root of 100, which is 10, so it's 15. All right. Let's first set up our critical value. If our significance level is 1%, where is our rejection region? First of all, it's a little rejection region. Is it here or is it here?
The left,
On the right.
the left,
I'm sorry, what are we looking at?
Rejection region.
the left.
On the,
On the left.
It's on the left. All right. It's going to be on the negative side here because anything above on the positive side we don't even worry about. We're like, yeah, sure, the null hypothesis is true. Anything below it we become concerned. Anything far below it, we say, I'm going on record as to saying that null hypothesis is false. What percentage of the sample outcomes are in this little rejection region?
0.1%.
1% of the sample outcomes. So if our sample outcome falls into that rejection region, bingo, reject the null hypothesis. So can you please tell me the critical value, the Z critical, that separates the bottom 1% of sample outcomes from the upper 99%?
So it'll be negative 2.33.
Outstanding. It's negative 2.33. That is the critical value for this test. So now, let's calculate our test statistic for this particular sample outcome. So we surveyed 100 data points. That's our sample mean. That's the standard deviation. So our Z stat equals 1955 minus 2,000 divided by 15. What does that come out to? How much? Negative 3. Fantastic. Negative 3 is the Z statistic. Alright, where does negative 3 fall on the sampling distribution of the sample mean? Well, it falls right about here, negative 3. Z stat. Stat equals negative 3. What is our decision? Reject. We reject the null hypothesis and we accept the alternative hypothesis.
Can you explain why? I'm a little confused.
Yeah, sure. Which part?
Like why would you reject that one and accept the other one? Or not reject the other one?
Okay, so we're going to assume the null hypothesis is true. The null hypothesis is that the true population mean is 2,000 or greater. Anything above 2,000, that's what the null hypothesis states. Maybe that's, some politician is saying, we make more than 2,000 widgets per day, or I don't know, I guess I'm mixing business and politicians, I don't know, mixing business and politics. I'm not sure if that's the best example, but for whatever reason, we are going to assume that that is true unless we have overwhelming evidence to disprove. So if that is true, all right, then we know our sampling distribution of sample means would look like this. It's normally distributed. It has qualities that we have studied. The mean of this sampling distribution, the sample mean, is the true population mean. And if the null is true, then that is 2,000. So we're going to go out and we're going to get some sample outcome, and we're going to see where our sample mean falls on this distribution. If our sample mean of 100 points of data, if it falls anything above 2,000, then we say, okay, I think the null hypothesis is actually true. In that case, we might even say we accept the null hypothesis. Normally, we don't say we accept the null hypothesis, we just say we fail to reject it. But if it's above 2,000, we might say, okay, we accept. If it's below 2,000, then we're going to start to get suspicious. We may have to reject this null hypothesis. Because you, politician person, business person, whatever, you told me that the mean was greater than 2,000, and I'm finding sample means that are less than 2,000. Okay? And I'm finding sample means that are significantly less than 2,000. And if it gets so much less than 2,000, then I'm going to reject what you're saying is true, and I'm going to assume the opposite is true. And not only that, I'm going to say I have statistical evidence that your null hypothesis is not true. Yes, Doc?
Quick question. When is it proper to use that you accept the null hypothesis rather than you fail to reject it?
Yeah, what I would do is I would just always say fail to reject, just to be safe.
So what do you say when it's below 2,000, but it's not in the 1%?
You fail to reject.
Fail to reject.
You're suspicious, but you fail to reject.
So you always fail to reject unless it's in the 1%, less than the 1%, then you say you reject. You're confident you reject.
Okay, you can't say yes,
You
right?
can't say yes, but you
But
can't
you have to
Right.
say fail to reject, so it's like, it might be yes or no, but not no, but it's
Right.
yes.
Remember that realtor, there's only a 3.29% chance he was telling the truth? Are you going to say, I accept that and I think you're telling the truth? No. You're going to say, I fail to reject that at this point. I'm not going to let you babysit my children, but I fail to reject at this point. Yes?
What's the difference between the ZC and the Z stat?
Yeah, okay. So the Z critical value, that was our threshold, our cutoff point between what we're not willing to believe and what we're willing to fail to reject. Yep, that was our significance level, and that's the threshold for what we're willing to believe.
I guess that was my question. That literally just cleared it up. So I'm
That
good
was
now.
cool, oh my god.
Team.
What about George?
Okay, one last little piece on this. We have already made our decision based on the critical value approach, but just for fun, let's calculate the p-value of this particular outcome. So I want to know the p-value of a z-stat of -3. Now I know it's less likely than 1% because I know it's in the rejection region. And there's only 1% of data in the rejection region. So I know this p-value is going to be less than 1%.
0.0013.
How much?
0.13.
Point-
0.0013.
Okay, yep.
How do we calculate that?
P-value equals 0.0013. Dina, can you explain how we calculate that?
From the Z table.
Oh, from the Z tape, oh.
Yeah.
So you just take the negative.
So you take the
three.
-3 and you look at the.
Look for it and just get, oh, okay, thank you.
Yep, that's the chance
So
of
the
being in
p-value is the
that
Z-score.
extreme.
So the p-value is actually the Z-score?
And you're gonna get in a lot of trouble if you start talking like that.
Math.
This is a Z critical value, this is a Z stat, and
But we find the Z-stat by looking at the table.
We find the z-stat is the
No,
calculation
I'm sorry,
based
the
on it.
p-value by looking at the z-table.
Yes,
You're right, tomorrow.
that's right, that's right.
You go negative two, you use P value.
Yeah, let's put that on there.
Hey,
Yeah.
alright, good, how are we feeling on that? Feeling okay?
Say
Go to
home
reject.
now. Go home now.
Just kidding.
Early dismissal, no
You got
problem.
She might leave us for a minute.
Got nothing to say to that.
That was great. Perfect time.
Alright, so let's do the next section. Alright, now we're gonna do two-tailed tests. And we just did a one-tailed test, now we're gonna do the same thing, but a two-tailed test. Let me erase this. Talk amongst yourselves. Wait, shouldn't have erased all that.
We're gonna get to Naruto later. Sometime. Oh my God.
Oh, it's tail.
Why are you yawning?
Tail and-
That was gonna be go to reject and test. That's it.
You've been doing one tail, now you're doing two tails.
Just kidding. Huh? Heads up. This? Oh, this is, oh. No, I don't. How do you take that out? Actually, we can cover this.
Alright, so we're back in this same realtor's office, and this is exercise 9.6. And the realtor at this point maybe brings out someone who knows lots of financial models and has more specific data. Or maybe, we had this discussion about less than or equal to 1560, and the realtor decides to double down and say, you know what? I'm going to go on record as saying that the true population mean is exactly equal to 1560.
Didn't we just do 9.6?
We did 9.2. Now we're doing 9.6.
That's the actual,
Page 337.
yeah,
Oh,
that's the actual question.
324. Sorry.
So previously the realtor says it's less than or equal to 1560, and now the realtor says, you know what? I've got exact information. It is exactly equal to 1560. So we just set up this problem a little differently. Because now there's going to be two ways to disprove what the realtor has said. We could find a really high sample mean, or we could find a really low sample mean. Both disprove what the realtor says. So we set up our null hypothesis. True population mean is equal to 1560. The alternative is the opposite of that. What is the opposite of that?
Not.
The mean is not equal to 1560. Alright? So it could be much higher than 1560, or it could be higher than 1560, it could be lower than 1560. It's going to have to be a lot higher or lower for us to reject the null, but really all this is saying is that it's something besides 1560. Okay, so let's now set up our sampling distribution of the sample mean. Okay. All right, the mean of this is still 1560. All right. We are going to believe what the realtor says unless we have overwhelming evidence to the contrary. What do we mean by overwhelming evidence to the contrary? Well, our significance level in this case is 1%. So anything less likely to happen than 1% in our sample outcome, we will reject what the realtor says and accept the alternative. So let's set up our Z critical values, and let's figure out the little rejection region or regions for this test. So, there are two ways I can disprove what the realtor said. A really high sample mean or a really low sample mean. So I'm going to have two rejection regions. One up here and one down here. Now, if we think about this, if the true population mean is 1560, then there's literally a 50% chance we might get a sample mean a little bit higher, and a 50% chance we might get a sample mean a little bit lower. So a little bit higher, a little bit lower, that's no reason to, throw a brick through the realtor's window, right? But as it gets further and further away, it goes from 50% to maybe 40% likely, 30% likely, on and on until we get to these tails. Now, if our significance level is 1%, how much area is in each of these tails? Yep, 1/2 of 1% is in each. So, can you please tell me the critical value for this and the critical value for this? The Z critical value that separates the upper 0.5% and the Z critical value that separates the lower 0.5%.
I'm sorry, Professor. How do we know what percentage is the upper and the lower? Do we have a hint?
You decided
we
the
do work with the
significant-
1%.
Yep, you decided that's your threshold for what you're willing to believe. In fact, we did that for you.
Yeah.
And we didn't do today's 10%. We chose yours.
So I guess half of 1%?
Well, we want the 1% least likely outcomes.
So we're looking for 0.005, would
Yeah.
be -2.5? Is that it?
Negative 2.5.
So I guess it's the same thing. Positive.
8, okay.
Oh,
Okay, yeah.
Yeah. And then positive 2.
Yep. So, negative 2.58 and positive 2.58. Okay. Now we have our rejection regions. And all we need now is our test statistic. Yeah, look for 0.005 on the negative side.
It's really 0.0049.
I see 0.51, because if you do 5.8, it's 0.49, so it's 0.49.
Yeah, I like the one as far away from 0 as possible.
Well, it's 0.0049 or 0.0051.
I would go whichever one has a z-score with a greater absolute value. Which in this case would be the lower.
Okay, so
You saw I was lost. That was like-
So that's the
Good
one
job.
Yes, you would. They worked out.
Okay, so let's